Hey guys, I decided to do something different for my project. I can't afford to do a simulation since we only have Windows 7 and not an industrial computer used by physicists, and I didn't want to do another boring PowerPoint since there are, only 7 different ways to style it? Nah. So today I'm going to do a low budget animation. That's pretty good considering my budget was 0, but no more procrastinating. Today I'm going to be talking about, drumroll please, quantum computers. So, what's so special about quantum computers? Well, we gotta discuss normal computers, which you should probably know about since there's one in front of you. Computers run on a bunch of different little parts, but today I'm going to focus on the transistor. To put it in the simplest form, it's a switch that lets electrons through. Those electrons are bits, but the smallest form of information. But computer parts are getting so small that quantum physics are starting to interfere. Transistors are now in 14 nanometers. Nanometers. That means people building computers will have to use a microscope, or a high-powered magnifying glass, or my prescription just to build your laptop. This may not seem like much, but now electrons are getting to the other side of transistors by a system called quantum tunneling, which is something extremely complicated that the only way I can understand it is if I go along in the lines of ape speak. So, this is what happens.
Particle go fast. Particle see still object that same size. Particle goes so fast you go through.
Oh, I regret doing that. Anyway, computer scientists saw this problem and said, how do we fix the problem? What they came up with was the quantum computer. So basically, what makes the quantum computer so special is that the smallest unit of measurement isn't a bit, but rather a qubit. Qubits are like normal bits, except they use a property called superposition. What happens in superposition is very complex, so I'll do my best to shorten and simplify it. Bits are either 0 or 1, like a light switch. Qubits in superposition can be both 0 and 1 at the same time, like when you were a little kid and tried to keep that light switch balanced. As long as the qubit is unobserved or unmeasured, qubits can be both variables. But when you look at it or measure it or observe it in any way, it has to be either 0 or 1. If you're lost with the explanation, just imagine it like this. Say you give your sibling your charger. I'm aware that some of you don't have siblings, but for the sake of explanation, pretend you do. As long as you don't ask it, you don't know if your sibling has it or not. Once you ask them, though, they will either have it or they won't. Now, what happens afterwards is none of my concern, but hopefully you get the point. Another property that is new and improved is the Qubit Manipulation. In a normal computer, you can have one input and one of many outputs. In a quantum computer, if you can cheat the system, which so far only a few brilliant mathematicians have been able to do, you can have one input and several outputs. What does this mean? Well, let's say you asked a computer what your favorite color was. A traditional computer would have to go through every single possible color by following the picture I put up here. While a quantum computer could just guess multiple colors at once using something like this, cutting the guessing time down exponentially. While quantum computers are a major upgrade to normal computers, they have a couple of downsides. Remember when I was talking about superposition? While it is true that as long as it's unobserved, it can stay in superposition, the qubit may have a hard time, staying alive. Because a property called decoherence, the qubit can decay when it's not being measured because the atoms keeping the qubit together will just snap off. But when we have the superposition problem solved and the right hardware for the quantum computer, we can have quantum laptops and Q phones, right? Nope. While quantum computers are excellent at calculations, they are much slower than a normal computer. While it'll probably be used for complex problems, it won't be there to look up cat photos. So, are quantum computers worth the millions, if not billions of dollars that people are spending on it? If you're a quantum physicist or a computer engineer, then yes. If you are everyone else, then you probably don't care if it's important.